Hello, everybody. I'm going to go ahead and start you off where we left off on Monday. Monday was the only morning that I saw you guys. Sorry about that. Today when I woke up, I didn't feel that great. So my wife told me to take a test. We had those at-home tests, So when I did that, I wasn't quite sure. I mean, it kind of looked like I was positive, but I wanted to be sure. So I made an appointment with my doctor and did one of those drive-up clinics, and they confirmed it. So seems like I have a mild case, but I don't know. Hopefully it doesn't get worse or anything. It just feels like I have a cold right now, and just kind of tired. And that's pretty much it. But we should be able to pick up for in-person classes on Monday next week. So that is, what date is that? That's the 20th. So I'm going to go ahead and this COVID protocol, I can't meet with you guys in person this week. So yeah, so I'm going to go ahead and just go through these notes. I'm going to go through what we didn't get finished on Monday. And I'm going to go through this. I'm going to make a video and I'm going to stop at 1.2, and I'm going to do a separate video for 1.2. I'm going to try to break it up a little bit. I know these videos can be kind of long and tedious, and it's not the best way, I know, rather than in person. But it is what it is. So let's go ahead and start up the rules for adding, subtracting fractions. All right. Sorry. These are popping up on my screen that I didn't want there. All right, we've got, it's a pretty simple rule. And the rule is that only add the numerators. Add or subtract, add or subtract. The numerators, okay? And then it kind of goes without saying that you should always simplify. When you're finished, you don't necessarily want to simplify the fractions when you're adding or subtracting. You kind of want to leave them as is, because sometimes when people simplify them, they no longer have like denominators. They have unlike denominators, and then that makes it impossible to add them the way you normally would add fractions. All right, so simplify, and that's kind of a general rule for fractions anyway, which is always to simplify fractions down to lowest terms. And, the lowest terms and simplest form, which we talked about on Monday. All right, so let's go ahead and dive into our first examples here. These are pretty simple to start off with. And what we're going to do is all we're going to do is add those numerators. That's it. 7 plus 2. And that's all you got to do. 7 plus 2 is 72, right? No, it's not 72. It's 9. 9 over 15. Okay, and we just leave the denominators the way they are, right? And then always ask yourself when you're finished with the problem whether it's in lowest terms. And in this particular example, it is not. We can divide the top and the bottom by 3. Both the numerator and denominator are divisible by 3. And then that will give us a fraction in lowest terms, or it should, because I'm using the GCF. So 9 divided by 3 is 3, and 15 divided by 3 is 5. Okay, so that's 3/5. And that's it. That's it. All right. Next one, number 17. Same deal, but this one is just subtraction. Okay, so 14 minus 5 is what we're going to focus on. Just do the 14 minus 5. Don't subtract the denominators, because if you do subtract 27 minus 27, that's 1, or not 1, that's 0, which ends up, making the fraction undefined. It's possible to have 0 as denominator. Just does not work. So we're going to go ahead and do that. So 14 minus 5, that's 9. Get 9 last time? Yeah. All right, but we've got 9/27. Okay, 9/27. All right, and then we're going to go ahead and simplify this into lowest terms. And we could, if you wanted to, you could divide by 3. Oops, I apologize for that. Sometimes my Apple Pencil gets a little screwy. We could divide by 3. But, then we wouldn't be using the GCF, and then we'd have to reduce again. So if we can, let's take the shortest route, which is just to divide by 9, because 9 divides into itself. as well as 27. So when you do that, you get 1/3. Okay, so 1/3 right there. And that's all we can do for number 17. All right, now number 18 and number 19 are mixed numbers. And there's a couple different ways you guys can approach mixed numbers. But for these particular examples, there's not a lot of there's not a lot of regrouping going on. So if you kind of just add corresponding parts, you should be okay. And what I mean by that is like add the, because these are mixed numbers, add the whole numbers. 4 plus 3 is 7. You do 4 plus 3 is 7. And then add the numerators. We've got 2 plus 4 is 6. And then we're not going to add the denominators. So we get 7 and 6/7. So that's one way to approach it. And then for this last one right here, what you might notice is that, when you add the fractions, when you add the ones, you end up with 2 halves, 2/2. All right, so if you write 6 and 2 halves, although that technically you did all the math right, 6 added with nothing is 6, and 1 plus 1 is 2. That is indeed true, but this part right here, this 2/2 is not quite in simplest form. So that can be simplified into, whenever a fraction is over itself, it equals 1. It equals 1. Now that the answer to this is not 1, it's going to be 6 plus 1. So that's what you're going to do. So that's going to be 7. That's the answer for that one. Okay. So those are pretty easy. I mean, when you have like denominators, not a tough deal. It'd be nice if all fractions were always like with like denominators, right? And it'd be nice, but they're not. And for a majority of this course, we're going to be dealing with fractions where we don't have a LCD. All right, and we have to find it, and we have to change the fractions. So let's go ahead and talk about that. So the rules for adding and subtracting fractions with unlike denominators is to, number 1, find the LCD, okay, the least common denominator, and then transform equivalent fractions or create equivalent fractions using the new denominator, because once you change the denominator, once that bottom number is changed, the numerator has to change proportionally to it. Now, a lot of us end up, when we change the denominator, some of us end up leaving the numerator the way it is, and that's wrong. Because, and you have to look at what factor it is, and we'll get into that when we get into an example here. But we're going to transform the equivalent fractions, and then we're going to simplify, which can kind of mean a bunch of stuff: add, subtract, and then also put it in Lowest terms. So finding the least common denominator is, I think we talked about that, or maybe we didn't. I can't remember. The last class, did we? Did we talk about LCD? No, I don't think we did. But anyhow, let's go through this. So the least common denominator, there's a couple different ways you guys could do least common denominators. One tried and true method is just to do the, good old-fashioned listing method. Okay, so let's say, we're not going to really do anything with these fractions other than just find an LCD. So let's say we have the fraction like 2/5. I don't like 2/5. Let's do 2/9. And let's say the other fraction is 5/6. Okay, so you got that 2/9 and 5/6. So what we're going to do is we're going to focus in particular on the denominators, and we're going to find the least common denominator. Okay, now LCD is really almost the same as LCM. I mean, it's the same process. You're finding the least common multiple of the denominators. That's what you're doing. So one way to figure out the LCD is to list out the multiples of each number, the 9 and the 6. And the grand question I always get is, how many times do I list it? Well, it kind of depends. Like some people kind of get it and they just list it as many times as they think they need to, but it really doesn't matter. So I'm going to go ahead and list off multiples of 9. Okay, so we're gonna do that. So I'm just gonna rattle off a bunch. Now I might pass the LCD during the process of this, but I'm just to be thorough, I'm gonna write down a whole bunch of them. Okay, so we got 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, and if I need to continue, I will. All right. And then the multiples of 6 will do the same thing. And again, just like I did with the 9s, I'm going to go ahead and just list off a whole mess of them. And even though I might pass the LCD, I just kind of want to make a point about the numbers that we get. So we got 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and so on. All right, and so if you look at those two lists of multiples, you're going to look for what they have in common. Okay, now the L in LCM or LCD stands for least or lowest. All right, so we're going to look for we want the lowest. Now, when it comes to LCD, really that L is kind of an optional thing. You could just leave the L out. I mean, really the important thing is that you find a common denominator. That's the important part. But the least common denominator is the way you kind of want to go because it's one of the easier ways to do it. Then you have less simplification. You have smaller numbers to deal with, less chances to make mistakes. So that's what we're going to do. So you might look at these and notice, okay, they both have 18 in common. Yeah. They both have 36 in common. And they both have a 54. And the comparisons there don't end just because my list ends. I mean, they're going to have more numbers in common as we kind of go down. If I were to list off more multiples, but as you can see, they, just from that list that I made, we have 3 common multiples there. Now, 18 is the one that I would use for this one. So that's what I would do. Now, sometimes people, when they do this, they can kind of just do it mentally in their head, and they're just like, they're thinking, okay, what's a number that 9 and 6 both are multiples of, and where they intersect? So sometimes people just rattle off in their head mentally, just using mental math, 9, 18, 27, 36, and they'll just kind of go, oh wait, 18, that's a multiple of 6 as well, so that's the number. But if it's not as intuitive as that, just like I just did here, list out the multiples. That's all you got to do. Let's list them out. All right, so for number 20 through number 20, 21, we're just find LCDs here. So yeah, we've got for number 20, find the LCD of 1/2 and 2/3. So we're going to focus on these things. We're not really changing the fractions. We're just looking for what that denominator is going to change into. So if you list off the multiples of 2, which is not hard, we got 2, 4, 6, 8. Very easy numbers to list out, right? And then you've got 3, 6, 9, 12, 15, 18, 21. Pardon me. And then you just start comparing, okay? And right out of the gate here, you can see, well, they both have a 6 in common. They both have a 12 in common. If I went a little bit further, you might notice that they have 24 in common, right? Or no, sorry, 18 in common. They also have 24 in common, but I didn't go that far with 2. But that's it. Yeah, that's your LCD right there. So your LCD for this one is just 6. That's all I'm doing is just figuring out what that number is, that we're going to change it into. All right, for number 21, we're going to do the same thing. We're going to list them out. So we got, let's list out some 2s, 2, 4, 6, 8, And again, it's a big question that people ask, which is like, how far do I go? And there's, it's just go as far as you think you need to go. And if you need to go further, keep going. All right, so we've got, I just listed out a whole bunch of multiples of 2. Now for 10, that's pretty easy. We've got 10, 20, 30, 40, 50, 60, 70, 80. Probably don't need to go any further. And then for 20, we got 20, 40, 60, 80, 100, 120, etc. And I'm just going to do what I have been doing, which is just compare those lists. All right, and and see what they have in common as the least common denominator. And I'm going to start with the biggest number, and it's got to be 20. They all have 20 in common as a multiple. All right, so that's the number. And sometimes when people do this, they start with the biggest number. They start with the biggest number, which I didn't do, but I was just kind of showing you how to do it. But to start with the biggest number, and then they kind of just work through it and go, okay, 20, is that a multiple of 2 and 10? And it is. And if it isn't, we can go to 40 and see if that's a multiple of 2 and 10. And if that's not, go to 60. And you can kind of just mentally, just do the mental math and approach it that way. All right, so for number 22, we're going to do the same thing. We've got 9 and 12 in this example. So you got 9, 18, 27, 36, 45, 54, 63, 72, 81. I'm going way past what I need to. 12, 24, 36, 48. These are multiples of 12, by the way. 60, 72, 84, 96. And again, just like before, I'm going way past what I need to. But these are all multiples. Now, remember, when you guys are listing multiples too, I think the most forgotten about multiple that sometimes is overlooked is the first multiple, 9 times 1. 9 times 1 is 9, or 12 times 1. Some people don't like to put those numbers down, but those are multiples. A number is a multiple of it, or the number itself is a multiple of it, right? It's that's the number that you can use as well. 9 times 1. 9 times 2 is 18. 9 times 3 is 27. And so if we look over the list here, we can see what they both have in common. And you might notice they have a 36 in common. All right. They both have a 72 as well. But 72 is not the least common denominator. We want the least common denominator, which is 36. Okay, so we did that. Mission accomplished right there. All right, so rewrite 1/3 with a denominator of 18. Okay, so what we're going to do here, and this is one of those things that you want to be able to do. So we're going to rewrite this with a denominator of 18. All right, so we want to know how many 18ths is 1/3. All right, so one way to approach that is just to look at the denominators that we do have. We have 3, and then we change it into 18. And we want to look at the multiplier there. What number do you have to multiply 3 by in order to get 18? So 3 times 5 is 15. 3 times 6 is 18. So it's got to be 6. So we're going to do the same thing with 1. So what we do on the bottom, what we do on the top, we kind of have to reciprocate there. So we're going to do 1 times 6, which is 6. 6 18ths. There you go. All right, so 1/3 equals 6 18ths. Those are equivalent fractions. They equal exactly the same thing. They represent the same part of a whole. One of them happens to be in lowest terms. 1/3 is, and 6 18ths is not in lowest terms. And the reason that we want to maybe write it with 6 18ths is because we need common denominators. All right, so don't get too worried that you're not dealing with fractions that are not simplified, because that's the point of changing the denominator. You want them to perhaps not be in simplest form because you want to have common denominators, because you're not allowed to add fractions until you have a common denominator. Very important that that is there. Okay, so let's go ahead and go through some of these examples. All right, so we have 4/9 and we have 4/9 and 5/12. So the LCD of 9 and 12 is 36. So what we're going to do is we're going to rewrite this problem. We're going to rewrite it with a new denominator of 36. Now notice I didn't put anything on the top yet, but 36 is a multiple of 9. 9 times 4, and 36 is a multiple of 12. 12 times 3. And now what we're going to do is we're going to change those fractions proportionally, meaning we need to really look at, okay, we need to look at what the old denominator was and what did it change into? What's that multiplier? And so 9 times 4 is 36, and so that's what we're going to multiply by on the top. So 4 times 4 is 16. So that's the new fraction. 4/9 equals 16 over 36. All right, now look, the denominator used to be 12 here, and now it turned into 36. So that's got a multiplier of 3. So that's what you're going to multiply by 5. You're going to do 5 times 3, which is 15. Okay, so you got 636 plus 1536. And we're going to add this up. So 16 plus 15 is 31 over 36. And as far as I know, that cannot be simplified. 31 is a prime number. And none of those, 31 definitely does not divide into 36 evenly. All right, moving right along, number 25. The LCD on this one is, we're going to go ahead and use 9. Now you might want to note here that for this fraction right here, the denominator does not change. It's a 9 before, it's a 9 now. Therefore, if the denominator doesn't change, you can just leave the numerator as it is. So we just leave that as 5. All right, so right here though, the 3 turned into a 9, which means we multiplied by 3. So 1 times 3, so that's what you're going to put on top there. So we have 5/9 plus 3/9. See, everything there is the way we want it. We want a common denominator. You're not allowed to add fractions, remember, unless the denominator is the same. And the numerator is all we need to add or subtract. In this case, we're going to add. So you got 8/9 right there. We're finished with that problem. All done. All right, now subtraction problem here. The LCD of 3 and 8 is 24. All right, in both instances, in both fractions, we change the denominator. So for 2/3, the denominator changed by a factor of 8, because 3, right? 3 times 8 is 24. So we're going to multiply the same value in the numerator. So we're going to do 2 times 8. 2 times 8 is 16. So 16/24 is equivalent to 2/3. It's equal to 2/3. It's not in lowest terms, but that's the point. The point is that we're changing the numerator and the denominator so that they have the same denominator. All right, for the other fraction, 1/8, that changed by a factor of 3, because 8 times 3 is 24. So we're going to multiply that on the top as well. So 1 times 3 is just 3. So we add, no, we're not going to add these. We're going to subtract. So 16 minus 3 is 13 over 24. All right, now moving on to number 27. On number 27, the LCD of 20 and 15 is 60. So you have 60 there. And for 3/20, that changed by a factor of 3, because 20 times 3 is 60. So that's what we're going to multiply on the top. 3 times 3 is 9. Okay. And then for 2/15, that changed by a factor of 4, because 15 times 4 is 60. So that's what we're going to multiply 2 by. So 2 times 4 is 8. 2 times 4 is 8. And now everything is exactly the way we need it, because you cannot add denominators, or you cannot add fractions unless the denominators are equal, unless they're the same. They have to be like. And so there we have it. We got 9 plus 8 is 17. 60th. Now for number 28, what I was just doing on this one is I would suggest changing these into mixed numbers, or sorry, from mixed to improper. So let's convert both those fractions into improper fractions. And the reason why I suggest that is because if there's ever any regrouping or borrowing, as it's sometimes called, borrowing can be tricky with fractions. And I think if we just change them into improper, that kind of leaves that whole bit out. You don't really have to worry about regrouping. So let's go ahead and do that first. Let's not find a common denominator. Let's just convert them into improper. Okay, so that's what we're going to do. So 4 times 3 is 12. And then 12 plus 3 is 15. So we got 15 fourths. And then this one we're going to do 6 times 1, which is 6, plus 5 is 11. Okay, so all we did first here was we converted those fractions from mixed to improper. Now the next step is going to be what we have been doing, which is changing it to fractions with the same denominator. So we're going to find the LCD. So the LCD of 4 and 6 is 12. So the LCD of 4 and 6 is 12. So yeah, 12 and 12 there. And then 15 fourths equals how many 12ths? Well, 15 fourths has a common, it looks like there's a common factor there of 3, because we're multiplying by 3, because 4 times 3 is 12. And so we're going to do 15 times 3. 15 times 3 is 45. And then for 11/6, that looks like it has a factor of 2, because 6 times 2 is 12. And so we're going to do 11 times 2 on that one. So 11 times 2 is 22. Okay. And now we're ready to subtract, which is the point, because now we have common denominators. So 45 minus 22 is 23. So 23/12. Now, like I remember saying on Monday, that it was okay to leave things improper. However, with this kind of problem, they started out as mixed. So if they started out that way, we might as well change them back to that way. But really, for finding slope or, any other situation besides a fraction problem, it would probably be okay just to leave it improper. But we're going to change this into a mixed number. So we're going to do 23 divided by 12. I know some of you guys can do this mentally, but I'm just going to show you how to do it just using a little bit of short division here, or long division, I guess. It's not so long though. So how many 12s divided into 23? Just 1. If it was 24, we could put a 2 there. So you get 1, and then 1 times 12 is 12, and then you subtract, and then your remainder is 11. So your remainder becomes the numerator, and your denominator from before is still the same. So 1 and 11/12 is a perfectly fine number or mixed number to express for your fraction there. Okay. One more example here. On this one, we have mixed numbers and we're adding them. And why don't we just go ahead and do the same thing? Let's go ahead and just change them into improper. So 6 and 7/8. So 8 times 6 is 48. 48 plus 7 is 55/8. Okay. And then 2 1/2. 2 times 2 is 4. 4 plus 1 is 5. So you got 5 halves right there. So 55/8 plus 5 halves. Now the LCD here is one of the numbers that we already have done, which is 8. So our LCD is 8, because 8 is a multiple of itself, 8 times 1, and 8 is a multiple of 2, 2 times 4. So we're going to rewrite it with 8 as a denominator. Now the first fraction, nothing changed. It was 8 before, it's 8 now, so we're just going to leave it as 55/8. For the second fraction, 5 halves, for 5 halves here, the multiplying factor here was 4. So you're going to do 5 times 4, which makes 20. Okay, so now we're all set to add. So 55 plus 20 is 75. So you got 75/8. And we're going to go ahead, just like before, we're going to change that back into a mixed number. So we're going to do 75 divided by 8. Top divided by bottom. That's usually a good way to think about it. Just do top divided by bottom. Or just do it mentally, like a lot of people do. There's like, how many 8s go into 75? Oh, I know what that is. But I'm just going to do it this way. So 8 divides into 75 9 times. And then 9 times 8 is 72. Subtract, and you got 3. Subtract, and you got 3 there. And so there you go. 9 3/8. That's our answer. 9 3/8. Okay, so that does it for the rest of that section. Okay, so I'm going to stop the video here. I'm going to pick up with another video for 1.2 next. And that's it. Okay, so make sure, like when I'm doing these notes, you're copying along with me, you're doing the notes, you're writing them down. I know that some of you may or may not struggle with this. Maybe this is really easy for you, but regardless, you should still go through it and make sure you're kind of following along. But that should be it. All right, guys, I'll see you in the next video.